AM means amplitude modulation. So we have forward direction and backward direction. Forward direction is modulation which takes place in the transmitter. Backward direction is demodulation which will take place in the receiver. Demodulation in the receiver. Okay. This is in the transmitter and this is in the receiver. So we have three methods in modulation. Simple AM, we have three methods. So first one, square law modulation. First one is square law modulation. Second one is switching modulator. Switching modulator. Third one is class C modulation. Class C modulation. In demodulation, again, we have three different types. Demodulation, we have three different types. First one, square law demodulation. Square law demodulation. Second one is envelope detector. Envelope detector. Third one is synchronous detector. Detector or demodulation, one and the same. Detector or demodulator is one and the same. Okay. Now, the first two methods in modulation, first two methods, square law and switching modulator, these are called low level modulation. Low level modulation. Here, message signal frequency will be less than 5 kilohertz. And the class C modulation, this is high level modulation. High level modulation, where the message frequency is greater than 5 kilohertz. Message frequency is greater than 5 kilohertz. Okay. Now we will take up one by one how it works, everything we will discuss. First one, I am going with square law modulation. First one, I am going with square law modulator. So we will take a summation point. We will consider message signal, carrier signal, both of them combined and given to a non-linear device. Given to a non-linear device. Then applied to a bandpass filter. Then applied to a bandpass filter. Here comes the modulated signal S of t. Now you are familiar with what is M of t, C of t, S of t. You are familiar with M of t, C of t and S of t. Okay. So after combining, I will give the name as VI input applied to the nonlinear device. This VI is nothing but M of t and C of t put together. M of t plus C of t put together, which is VI input voltage given to nonlinear device. Okay, this is the block diagram of square law modulator. Otherwise, we can also take the diagram like this. We will be taking C of t. We will be taking C of t and message signal. We will also take one DC for operating point. Non-linear device means example diode. Basic example is diode. Then we will take LC combination. After the diode, we will take LC combination, inductor, capacitor. One inductor and a capacitor. Inductor and a capacitor. And here the output is taken. Output is taken. If I use the same representations, then we will not have any confusion. You will understand what I am talking of. I am putting inductor and capacitor L, C. Here comes the output S of t. This is the diode, which is a non-linear device. Okay. So both of these diagrams you can use for square law modulator. Okay. So what happens? The signal should be very small. Applied signal should be very small. Okay. So applied signal should be small in order to maintain the nonlinear characteristics of the device. To maintain or work with nonlinear characteristics. Diode will work with nonlinear characteristics when input is a small signal. And then it will give output, and that output is given to band pass filter, and it will give the spectrum of S of t. It will give the spectrum of S of t. Okay. And this nonlinear device, it cannot remove all the unwanted frequency components. So we are putting a band pass filter in additional. Okay. So this diode, it cannot remove all the unwanted carrier components. Cannot remove all unwanted frequency components. We will take frequency components. That's the reason we are going for band pass filter. That's the reason we are going for band pass filter. So what this band pass filter will do, it will remove all the second integral term. It will remove the second integral term. So the higher frequencies are removed. Second integral term, higher frequencies are removed. Okay. So if you remember the spectrum, message signal spectrum is something like this. If I take a triangle, and this is M of F, spectrum of message signal, and modulated signal spectrum will be two triangles. The same center origin triangle is shifted left and right, and it is with respect to plus Fc and minus Fc. With respect to plus Fc minus Fc. This is S of F means spectrum of S of t. Spectrum of S of t. Okay. And this is given by a band pass filter. This spectrum is given by a band pass filter. A range of frequencies are allowed. You can see, I will put a dotted line. Band pass filter behavior is applied. Band pass filter behavior is applied. Okay. On the left side also. On the left side triangle also, a band of frequencies are allowed. These are the band of frequencies. These are the band of frequencies. Right side it is Fc plus FM. Left side it is Fc minus FM. Okay, right side Fc plus FM, left side Fc minus FM. So what we are trying to tell out of all this, you can see message signal given. If you give a small frequency message signal, the nonlinear device can work in its proper behavior characteristics, and it can produce a output. And then all the components, unwanted components, cannot be removed by the small diode alone, because the nonlinear device is nothing but diode. Nonlinear device is nothing but diode. Okay. And the LC combination, LC parallel combination, this works as the band pass filter. This LC tank circuit or band pass filter. This is tank circuit or band pass filter. So in the spectrum, if you see a single triangle, it is shifted to left and right, and a range of frequencies are allowed. That is the band pass filter characteristics. Okay. And they can remove the more unwanted frequency components. Diode alone cannot do so. So we are taking help of band pass filter. It will also remove the unwanted frequency components. Okay. So coming to the Vi in this diagram, before the nonlinear device, we are having Vi. That Vi is nothing but message signal and carrier signal after applied to the summing point. So message means AM cos 2 pi FMT, and carrier means AC cos 2 pi FCT. This is the Vi input to nonlinear device. Okay. And output of nonlinear device, output of nonlinear device, it will have a behavior A into Vi plus B into Vi square. A into Vi plus B into Vi square. If you substitute the entire thing, I will not simplify, just I will substitute and show you. A into Vi means AM cos 2 pi fmt plus AC cos 2 pi fct plus B into VI square. VI square means AM cos 2 pi fmt plus AC cos 2 pi fct whole square. B into VI whole square. So when you expand this, it will become cos square, that is the second order. Okay, higher frequencies, FC square will come. And all those higher frequency components, unwanted components will be removed by the bandpass filter. So finally, on simplification, what we are going to get is AC 1 plus KA, okay, KA AM or KA M of t cos 2 pi FCT, and this is nothing but S of t, final output of bandpass filter. Okay, output of bandpass filter. So bandpass filter will remove all the higher frequency components. So after that, at the output of bandpass filter, we are already familiar with the equation of AM. We are already familiar with the equation of AM, AC into 1 plus KA M of t cos 2 pi FCT. Okay, this is the output we are going to get at the bandpass filter. This is how the square law modulator works. This is how the square law modulator works. Okay. Next, the second method is switching modulator. Second method is switching modulator. Third one is class C collector modulation techniques. Class C or collector modulation technique. Okay, class C or collector modulation. Class C amplifier is used in that, so I have directly written that collector modulation technique. Now I will go to the methods in demodulation. The square law modulation is very, very important. Now coming to demodulation technique, square law demodulator. Square law demodulator.